It's going to be a continuation of the part 1 video. So in example 3, pause the video, copy that down. Again, pause the video, copy that down. Alright, so with this time it's in the y-axis, which means it's respect to dy, which means everything must be in terms of y. Okay, and you can already see that it's solved for x, which means everything is in terms of y. But in order for me to graph it, I have to make it y equals. Maybe you don't, but I do. So that's going to be plus or minus radical x, and that's going to be cube root of x. So now I can go ahead and graph my two graphs. Now with this one, I'm not so sure which one is going to be on top and which one is going to be below. So for that reason, I'm actually going to make a table just so I can check it. So it's between 0 and 1, so I'm going to pick values between 0 and 1. Plus or minus radical x is going to look like this. So that's the positive one, and then also the negative one. But I'm not sure if this one's underneath it or below it. I mean underneath it or above it. So I'm going to pick points between 0 and 1. So if I pick y as 0, I'm going to get x as 0. If I pick it's a half, I'm going to get 1/8. Because I cube it, I get 1/8. If I pick 1, I'm also going to get 1. I'm going to do the same thing for x equals y squared. So again, I'll pick, and 0, 0 is 1 and 1, so I'm just going to check what happens at a half. When y is a half, squared would be a fourth. So now I'm going to label a half on the y-axis, and on the squared one, it's going to be 1/4. Now that same 1/2 on the cubed one, it's going to be 1/8. Where's 1/8? Right there. So that means 1/8 and 1/2 is right there. So that means that graph is on top. So that's how I know. Alright, so the y cubed graph is on top and the y squared graph is on the bottom. Very important for which one belongs where, because it's going to determine your answer. It changes your answer actually. Alright, so once we've done that, we're going to rotate that shape on the y-axis. Okay, so I'm going to draw the shape again. So y squared on the bottom, y cubed on the top, and I'm going to rotate it on the y-axis, which means I'm going to reflect it. So go ahead and draw the exact same thing on the other side, reflect it. As a listening check, put a box around example 3. And that's my disc. Again, the disc is the one with the hole in the middle. So that one has a hole in the middle again because there's a space between the y-axis and those two curves. So what is the shape of my cross section? It's still a circle. So you're going to go connect your inner and your outer circles. So that's what I'm looking for. Infinitely numbered from the top to the bottom is going to give me the volume. To find the area of each one, I can find the volume. So little r and big R again. So the r, big R is for the outer, the little r is for the inner. Alright, so the area is, remember, the area of the outer minus the area of the inner, because this one has a hole. If it didn't have a hole, it would just be the area. So the radius for the big R, for the outer, we can see that it's going to be y squared, because y squared is the one on the bottom, and then r squared is going to be y squared squared, which is y to the 4th power. Then little r is the one on the inner one, so it's going to be y cubed, and then that squared is going to be y to the 6th power. Alright, so following through with what the area would be, it's the outer, which is pi, big R is y to the 4th power minus pi, and then y to the 6th power, because the circle is pi r squared, which I can factor out pi, which will leave pi to the 4 minus y to the 6, and then the volume is the integral of that from what? From 0 to 1, but remember it's in terms of dy, so everything must be in terms of dy, including the interval. So the interval from 0 to 1 of the area with respect to dy. Again, calculator, math 9, parentheses, the function, which I'm going to put a pi, close it, and then times the next function, which is y to the 4th minus y to the 6th. In terms of, I don't have a y, so I'm going to use x. Close it. With respect to, I don't know how to do the y, so I'm doing the x because everything I've put in terms of x now. And then my interval from 0 to 1. And to the nearest 3 decimal places, that's going to be 0.180. Again, pause the video, make sure that you can get that, rewatch it, and make sure you're on the same page. Alright, let's take a look at another example. This is actually an AP question I've come across. It says, find the volume of the solid that results when the area bounded by the curve y equals x squared. This is a listening check. Underline example 4. So find the volume of the solid that results when the area bounded by the curve y equals x squared and the curve y equals 4x is revolved around the line y equals -2. So again, AP question isn't necessarily the x and the y-axis, they give you a line, but the process is the same, it's just one little change. So set up the interval but don't evaluate, just to save time. Alright, so first thing you do is, of course, you have to sketch it. So that's what x squared looks like. Then the line y equals 4x, it goes through 0 with a slope of up 4, right 1. And that's rotated around the line y equals -2. So you go to the x-axis, go to -2, and draw a horizontal line. This is a listening check. Color in set up but don't evaluate. Color in set up, don't evaluate. So that's the line y equals -2. So we're going to take that little shape, the area between those two curves, and rotate it around that. So we're going to redraw this just with the little shape I'm looking for, but we also need to find what a and b is, the interval. Okay, so how do we find the interval? You set them equal to each other because you can see at those points they're exactly the same. So what does that mean? That means x squared, the red one, is equal to 4x, the green one, at those 2 points. Take 4x to the side, so x squared minus 4x equals 0. Factor out x, solve for x, x equals 0, x equals 4. So it meets at 0 and 4. Now I'm going to just draw that little area I'm interested in from 0 to 4. And I'm going to put in my curve, so putting in my line 4x and my curve x squared. And I'm just going to extend the line of rotation, which is -2, y equals -2. And so again, next thing to do is reflect it. So I'm going to reflect that shape over my line of rotation, which in this case is not the x-axis or the y-axis, but a line. So it ends up looking like this when I flip it over. Alright, so what shape is my cross-sectional? Again, it's still a circle. So I'm joining the green line, making a circle with the green line. And I'm going to make a circle with the red line. So again, we see there's a hole again, so we're going to be subtracting the outer minus the inner. So we need to figure out the big radius and the little radius. So big radius being the outer, little radius being the inner. So let's go ahead and draw a cross section. And again, that goes from 0 to 4 on the x-axis. And we're just flipping it or rotating around. Alright, so my cross section. And this is with respect to dx because you can see it's parallel to the x-axis. So very important, everything must be in terms of x on this question because it is parallel to the x-axis. This is a listening check. Put a box around x equals 0, 4. In other words, my rectangles are perpendicular to that line. Alright, so big R is going to be the same thing as before, only we're going to add 2 because that's the distance right there. So it's not just the little part we found before, but it's 2 plus that little part. And we're going to add the same thing 2 to the little r. So it's r plus 2 is the small radius, big R plus 2 is the big radius. So that's going to be, the big one is the line 4x, and we're going to add 2 to it. We're going to square that, it's going to be 4x plus 2 squared. Little r is x squared. We're going to add 2 to that because it's not just the space from 0, the x-axis to that line, but including that additional 2 units and square it. So area is, remember, the area of the outer minus the area of the inner, which is, I'm going to factor out the pi because I hope you've seen enough questions to know that there's pi in both of them. Pi r squared is the area of a circle. So factor out the pi, and that's going to leave the outer, which is 4x plus 2 squared, big R, minus little r, x squared plus 2 squared. Okay, so that means the volume is the integral of the area with respect to dx. That means the interval is from 0 to 4 of the area. So we're just rewriting the area out with respect to dx. And the question says, write it out, don't evaluate. Some of your AP questions will say that. Now let me take a look at one last example. Let's say it's the same question, but what about if it's rotated about the line x equals -2? So instead of y equals -2, x equals -2. So we're going to copy that exact picture down since we already know what it looks like. And instead of rotating it around y equals -2, we're going to rotate it around the line x equals -2. So go ahead and draw in your line x equals -2, which goes to the x-axis at -2, and it's a vertical line. Same deal as before, go ahead and do a mirror image on the other side. Color in what about rotated about the line x equals -2. In other words, color in the sentence with example 5. And again, this one still has a hole because there is space between the two curves and the line of rotation. Let's see what our cross section looks like. So make a circle, it's a circle again. So make a circle from the red to the red, and then from the green to the green. And then color that in. So we're talking about infinitely many discs. I'm sorry, washers. Alright, so let's go ahead and draw what our cross section looks like. And this one's actually, so this one, you see, it's not just the distance from the y-axis to the curves, but we're going to add 2 to that. Everything must be in terms of dy. So it's going to be big R plus 2 and little r plus 2. Because the distance from there to the axis and then to the curve itself. Again, the distance to the axis and then to the curve itself. Alright, so everything must be in terms of y. So little r, so we're just going to label it actually y equals 4x and y equals x squared. I'm going to solve it for x, so I'm going to get x is plus or minus radical y, and x is y over 4 because everything must be in terms of y. So little r is going to be y over 4 plus the 2, because that's the green line, it's the inner. And then square that, and it's going to be y over 4 plus 2 all squared. Big R is going to be 2 plus radical y. We're going to ignore the minus because looking at it, it's on the positive. So 2 plus radical y, and then capital R squared is 2 plus radical y all squared. I don't know why I forgot to put the squared. I guess I'll put that in later, but all squared is capital R. Again, it's because that little piece is 2 above what we usually do, so you have to add on that 2. Alright, and then in this one, we're not given the interval, so we need to find out the interval. We need to know what happens from 0 and to 4, the y values. So let's find out what those y values. Well, at f of 0, it's 0, and then at f of 4, whichever one you plug it into, you're still going to get 16. So our interval goes from 0 to 16, because it has to be in terms of y. Remember, if it's dy, everything must be in terms of y. So the area is the area of the outer minus the area of the inner, which is, again, they both have pi, so factor pi out. And the area of the outer is going to be radical y plus 2, capital R, squared. And I guess I'm going to put it in now because I just realized it. Look at that, I just realized it. Alright, minus little r squared, so y over 4 minus 2 squared. And then the volume is the integral of that thing from 0 to 16. Must be in terms of y because everything is in terms of y. So write down the whole area and then with respect to dy. And that's pretty much it. So most of the AP questions that I've come across, they're not actually even going to ask you to evaluate it, they're just going to ask you to set it up. Let's practice.